Now for these examples, we're going to be simplifying fractions using the prime factorizations of the numerator and the denominator. After that, we're going to cancel common terms. Here's how we're going to approach these types of problems. So first, we're going to get the prime factorization of 4. I'm going to go ahead and write 4 here. I'm going to do some side work and get the prime factorization of it. I can see that here the only combination that's going to work is 2 times 2. And 2 is a prime number. So I can rewrite the 4 as 2 times 2. So my numerator became 2 multiplied by 2, the prime factorization. We're going to do the same for the denominator of 44. I'm going to write 44. Here's my side work, and I'm going to get its prime factorization. 44, we can say that that's the same as 4 times 11. And then 4, we can break it down into 2 times 2, and the 2's are primes. If we take a look at 11, the only possibility is going to be 1 times 11, meaning that this number is prime. The prime factorization of 44, I'm going to write it here on the denominator as 2 times 2 times 11. So 2 times 2 times 11. And now I'm going to follow this part right here. I'm going to cancel common terms. So here I have a 2 that's common on the numerator and the denominator. I'm going to go ahead and cross those out. So these 2's are common, so I can cancel them out. And I have another 2 in common, so I'm going to cancel that one out with this one. So here, all I'm left with is 111 on the denominator, and on the numerator, here we can say that there's an invisible 1 being multiplied at the top. So our final answer would be 1 over 11. That would be the simplification of 4 over 44. Let's try one more. So now here we have 16 over 20, and we have to follow the same instructions here. Let's begin by getting the prime factorization of 16. So here I know that 16 is the same thing as 2 multiplied by 8. And here I have a prime in 2. 8, I can break that down into 4 times 2. So I have another prime right here on the right. And then 4 is the same thing as 2 multiplied by 2. And I've succeeded in decomposing 16 into its here product of primes. So let's write the equality symbol. In the numerator of 16, I'm going to rewrite this as its prime factorization, or its product of prime factors. So here I'm going to write 2 times 2 times 2 times 2. Let's do the same thing for 20. So 20, I can say that this is the same thing as 2 times 10. So I have a prime on the left being 2. And then 10 is the same thing as 5 times 2. And 5 is prime, 2 is prime. They're all prime because the only possibilities are 1 in itself. That's the only product that's going to work if we're looking at integers or positive whole numbers. So here we're going to take a look at the 20 and rewrite it as its product of prime factors being 2 times 2 times 5. So 2 times 2 times 5. And now we can follow these instructions right here. We gotta cancel common terms. So here I can cancel 2 2's from the numerator and the denominator. So this 2 cancels out with this 2. This 2 cancels out with that 2. Now whatever's left on the top, we multiply it together. So 2 times 2 is 4. And then 5 is the only number on the denominator, so that one's going to be the only thing we put on the denominator. And hence 16 over 20, the simplification would be 4 over 5.